Ladies and gentlemen, welcome back. We'll have the afternoon session of this PyCon. The next talk will be about unlock the power of Insurtech. It's a case study of digitizing the risk assessment in insurance using powerful Python libraries and optimized performance with advanced machine learning models. In this talk, we will have two speakers. First one, Rodrigo, is a data scientist passionate about knowledge discovering and encouraging companies to take data-driven decisions. Most of his career experience has been in insurance and e-payment industries. He holds an MSc in Big Data from Hong Kong UST and an MSc in Operations Research from Los Andes University. Second speaker is Calvin Cheung. He is a data scientist with several years experience in fintech startup and insurance industry. Prior to starting a career as a data scientist, Calvin was a climate scientist, and his research involved in using statistical models and machine learning algorithms to predict the impacts of climate change. With a PhD from Hong Kong University and a postdoc from SCIKIT, Calvin is a member of Climate Informatics and passionate to apply data science in climate application. So now let's welcome our two speakers.
Thank you. So, hello everyone. Well, this is Rodrigo, this is Calvin. We're both colleagues. We work for an trade insurance company as part of Allianz Group. We basically wanted to show you what we do without showing, let's say, the real data. Well, we came up with some open data sets, and we will try to tackle it basically, trying to show basically what we do in our daily lives. So we divided this talk in two parts. So the first one is how to read data when it's not as clean as we would all like it to be, and second one is basically the use case and how we can use machine learning to, let's say, for the assessment. So for the first part, well, in case anyone is interested in following the, let's say, the notebook, it's in Git. So yeah, it's right here in case you want to have a look. If not, then it's totally okay. So okay. So for the first part, we found some good data set from the Small Business Administration. This is an organization in the U.S. that basically will try to help small business to basically to get along, right? So basically they give from loans to trainings. They analyze how policies and regulatory environment can affect the small business companies, small and small business in the U.S. So yeah, so basically the website is this one. Well, here you will find all the information on what they do. Oh, just like small lag. And well, and right here you will find a list of PDFs. Basically, well, let's if we click the first one, you will have a description for each state in the U.S. having let's say some descriptive data, the let's say number of companies, the employment they create, some figures here, some economic analysis here. Some tables, some figures, basically again describing how the small companies are in for each state. Well, that one was for Alabama. This one is for Alaska, and I think you guys now know where we're going. So, well, in case you want to download data, we can. Oh, okay, yeah, it's taking some time. Well, if you use with Beautiful Soup, we can go to the website and basically extract all the data, all the PDFs, download them to your local machine or wherever you have it on the cloud. Okay, so I guess that's all for the first part. So let's start exploring it. If you Google search or Stack Overflow how to read PDFs, probably you will come up with the three most used libraries. One would be PdfMiner, Tabula is also quite common, and then PyPDF2. So let's have a look on how all of them perform reading the same PDF. So okay, so with Py2PDF, the function that basically does all the magic is this one, where we can extract the text of the PDFs. And if we don't, so let's say before trying to set up all the things, this is how it looks like if we just try to read the PDF calling the function. Of course, I guess this is not quite quite easy to understand. Basically, you have here each paragraph is one page, and so again, so if we look, for example, for this part, the small business, and this number 382,000, you will find it right here, right? So how to make this work? Then you can tune somehow the parameters to make some space between words, and for the tables you can see the information here. So you will have it like in a line, and then you will have to split it and keep working on that. So if you want to get if you want to use the data, right? Good thing about this one, it's quite fast. It converts everything to text in just in a couple of seconds. It's this one, it's really fast. Now, if we try with Tabula, this one is a wrapper of Tabula in Java. So this is a wrapper of Python using basically the same library. This one, the easiest way is just calling read PDF. Let's say quite straightforward. And as you may guess, well, Tabula is good for when we have tables. So for the first part, it looks quite messy, again, without pre-processing anything, doing any processing on the data. So you will have some tables here, but now the real tables, if we look here for what the part of the information that is in tables, it looks quite well, without doing anything like anything fancy, right? So this is the table here, and you see how it looks with Tabula. Final one is actually PdfMiner. I found this one called PDF Query. It's a wrapper of PdfMiner, but it basically allows you to query a bit easier for me on how the objects are loaded. So so let's say this one takes some time. It will extract all the information from the PDF into objects and will give you the coordinates on where the information is. Now with PDF Query, well, it's let's say you can query the text, let's say you want to find. So for example, if we look for the words small business, it can tell us which position is it, what page, and so on. And if we extend that a little bit, if we want to have just the line or we want to have the box where the information is, then we can retrieve it. So for example, for the part of small business, here we have again the 382,000 and so on. So with this one, well, it's quite easy when we know, for example, the for this table here, when we know the let's say the keys for the rows, then we can just call a function, give me the information that is right next to these keywords, like retrieve that information, and we can create a dictionary easily with all the, let's say, retrieving the information. And when we have a proper table, then again is find the title of the table and then keep iterating and keep retrieving the information in front of it. So it will look just like this one, right? And yeah, from here, yeah, from the list of dictionaries to pandas, the data frame is quite straightforward. So now we have actually, how many states in the US? I don't really know, but so let's say we try to retrieve all them at once. Probably the easiest way is just, we create a function. Let me see, where is it? Okay, so these are all the small functions to retrieve the information. Then we create just one big function calling all of them right here, and then if we'll assign one, let's say, one worker to retrieve the information for one PDF, then it's always good to have something that will tell you, hey, this is taking too long, just abort the mission. And then, yeah, we can just call it all at once, multiprocessing. We can read all the information quite easily. So here you have the list of dictionaries, tables, and so on. So you can see it looks quite clean without much coding. And then, well, we can just remove the commas, the percentages, and so on. And there it goes. There we go. We can easily have the tables and bind all the information together. Without much work, and then it's ready for the analysis. I think I'm taking Calvin's time right now, so I'll just wrap up now. So, well, when you have the information, then it's quite easy to make the analysis. Sorry, man. Your turn. So yeah, now Calvin comes with the use case after you have everything super clean. Go ahead.
So the reason why we need to use machine learning, okay, first we want to use the machine, so it doesn't need to use too much labor, so you can save cost. Another point is because the machine can perform much better, so you can actually reduce our risk, and that's why you can use the machine learning to make money. So here is demonstrate how to use machine learning to save money. So the notebook is in my GitHub, so maybe later you can just download it. And so here is a notebook viewer. You can just open it. It's much easier. Okay. So a bit introduction of the SBA. So basically, they are a government body. They okay. Let's say the bank. They approve loan to this company. So this company may use the money to keep their business, expand or retain their employee. But sometimes they may not be able to pay back the money. So I mean, if you are the bank, then you wouldn't want to borrow your money, because if you are not going to get back your money, then there is no deal. So this is where SBA come from. So they will approve a part of the loan. So if these companies are not paying, then the SBA is going to recover it. However, SBA is not is not going to approve every single one. I mean, it's not going to approve the total amount of the loan. They will only approve a certain percentage of the loan. So the bank is still taking some of the risk. So here is my case study. What I'm going to do, okay, I'm going to use the data from 2003 to 2004 to create a portfolio, and that I use it to train my model and also to validate my model. And then I'm going to use this model to predict the data from 2005 and compared with the performance from the SBA with our machine learning grade. I'm afraid it's a bit small here, but if you can download the notebook later, then you can see all the calculation very clearly. So basically here I'm just showing like because the SBA they will have a the percentage of the loan. So let's say if they are granting like 100%, then I will assign it as like a grade 1. If they're only assigning less than 20%, then I'll assign it as a grade 5. So from here, let's look at the data first, okay? So I'm doing a EDA for the data set. Oh, I'm sorry, it's a bit small in here. Okay, but I can briefly introduce a variable. Okay, you got the name of the company, you got the zip code, which gives you the location of the company, the ratio of the business, which is a lease code, and the number of employee. Something like if it is a franchise, or if it have been loan before, so I use the data set to see if this is their first loan or they have some previous loan record. And also their business type. Also create some feature, for example, the suffix of the company. For example, if it's let's say McDonald's restaurant, then restaurant at the back of their name is mean that I know that they are a restaurant. But sometimes, for example, some law firm, they will have like LLP at the back, so that will further divide which group of this business. Here I got the historical data. Maybe I show you. It look a bit interesting. Okay, yeah. So anybody know what happened in 2008? Anyone? So you see why it's so high in here, right? Okay. Okay. So for different sectors, so you also have some of the sector have a high risk. For example, the real estate, financial insurance. Yeah. Yeah. Okay. Okay. So let's move to the next one. For the machine learning, okay. I have that data set, it's clean already. So you got all the features. So what I'm going to do is just going to put it into a machine learning, which the algorithm I use is the XGBOOST. For this part, I'm not spending too much time to optimize the algorithm, but the most important thing is I'm using this algorithm to output a probability, and I'm using that probability to plot a walk curve, which is like this, okay? So the magic part is, okay, you have the walk curve, so how do you distinguish the like good company and bad company here? So here you have to set some of the threshold, and then you can create different grade in here, you see? So let's say if the probability is very low, then it probably is like grade 1. But if it's a very high, then it's like probably a grade 5. Also, interestingly, we'll be looking at the feature important. So in here, some of the feature have a very high contribution. For example, the zip code, the type of business, the lease, yeah. The lease is the different company sector, okay? So after I got this grade, I can apply this same model to the 2005 data. Let me go back to this notebook. So here I have comparing the performance from the SBA and the performance from the machine learning grade. So maybe let's jump to the result. Okay, so the total insurance amount is kept like similar, but the total amount of claim from the machine learning is significantly lower compared to the SBA. And this gives us a much lower loss ratio. So you may think that, oh, okay, what is the grade distribution here and why it does the magic? Okay, then you can see in this chart, okay, in here you can see the number of cases in different grades, and for the SBA, most of their grade is in grade 3. It means that most of their loan they will only insure for 50%, but they are not distincting like good company or bad company. And even for they approve for like 100% one, then actually the loss ratio is also quite high in the grade 1 in their portfolio. But in ours, we distinct we have a much lower claim in grade 1, and we have much higher claim in grade 5. But since that we only approve very low percentage of our loan in grade 5, so the overall risk will be much lower. See? Yeah. So the next part I will show. Okay, you create a machine learning models, but how do you convert it back to the business? Okay, I mean, let's say that if you are the underwriter, then you got that machine learning grade from this model, but you often have to deal with your client. So how are you going to explain to them? So for machine learning, we can use the XGBOOST, use the 85 library to you can go back and then see how which variable is more or less important for your machine learning model. For example, this one import the 85 library, and you can see that here for the overall, the zip code is important. The city is important. But for individual case, how do we do it? Then we can use the show prediction method. Okay. So for example, this with one of the cases, 55707. So this is a company called what trader, something like that. Okay. So they how do we come up with the grade? How come we give them a grade 1? And it's because they have a low risk in their location, or they are in a good industry, something like that. But still, you have a variable like this, then it's still quite messy. Okay, you can't really explain to your client in like 5 minutes. Okay. So what I'm doing in here is I will group those sectors together to become the sector group. For example, for location, that will use some of the feature. For example, like the state of the bank, the flip code, is it located in urban or rural? And then I will have the business size is let's say the number of employee, and the sector, and the loan quality. Let's say which bank approved that. I mean, if it's a bank that they love to approve for everything, then surely the loan quality is not that good. So the risk will be higher. And then I can, because I only end up with, let's say, a 6 variable group, then I can plot it into a radial graph. So it becomes something like this. So here I'm sure, oops. So let's say a good, sorry, there's a lot between this connection with this one. So this one is showing that that's a good company. So let's say the location is good. Maybe it's located in some places that business level 4. Also they have good record, and the loan quality is not bad. And then compared to a bad company, like this one, is definitely showing that it has a much higher risk. For example, the loan quality is not good. So maybe they are loaned from a smaller bank, and the business size maybe is a very, very small startup. So there may be a higher risk for them to not able to pay back the loan. So so here it is. This is the user case of a credit risk insurance. Thank you. Any question?
Can I ask a question about the hyperparameter tunings in XGBoost? Do you recommend using grid search or other Bayesian approach?
Yeah, you can use like grid search. For example, you can use like random search, then you can much faster to get your model into a more optimized state. Also, some people will use different machine learning model, maybe like the XGBoost or CatBoost or the LightGBoost, and then they get an ensemble for that. But for this example, I'm trying to demonstrate just a machine learning model can create a much better performance compared to the existing one, and this is how it is going to be so useful. Yeah. Any more question? Yep.
This might not be related to your presentation directly, but
wondering how you think that, because you have interest in climate change, right?
Yeah.
How will climate change affect the insurance industry over the coming years? Is that something that you've been able to draw a connection to?
Yeah, sure. Of course, I mean, the future climate change will have a lot of impact to our society. For example, I mean, the extreme temperature will be affecting the building. Let's say the building here is based on, probably it's based on the weather data for the past 100 years. But I mean, for the future climate change, it's going to be, it's going to experience a lot more like extreme condition. Even let's say the drainage system, then, I mean, if you have a extreme rain event, then this may screw up the drainage system, then it surely will be affecting the insurance to ensure the building is in a operation of a building. So this is a lot of risk involved. Any more question?
One more question, sorry.
Yeah.
What libraries are you using to visualize in your Jupyter notebooks?
I use Plotly.
Okay.
Yeah. Do you like Plotly?
I haven't used it, but I noticed that when you were moving the cursor around the figure, there are some.
Oh yeah, it's interactive. There's some library can do the same thing. It's like the D3 and the Plotly library is also very good. Yeah, they are excellent open source stuff. I mean, if you like data visualization, then you have to go into it. It's really, really good.
Thank you.
Any more questions? Yes?
So in your result, you show that the zip code is actually one of the most important features.
Mm-hmm.
So does that mean that geographically where does the business is running means that it's easy to get default or not? Is that the case, or you look into other
Yes,
features as well?
actually, I was like skipping some diagram here. So here, I did show that, but I didn't show in here, sorry. So a lot of the cases is located in here. I don't know, like California and Florida, they have a lot of these loan cases. But when we look at the default case, and I mean, if you compare these two map, then you can see that it's very high amount, a lot default case around here. So when you compare the default rate across the US, then well, you do see some of the location has a much higher default rate. So that become one of the more important feature in my model. And well, I haven't got time to go there to see why the business is always screw up. Hopefully, I will have this opportunity in the future. Any more questions? Rodrigo, you want to say something?
No, I was just adding to your question, then just think of it, let's say cyberport. So how many companies do you have registered with addresses in this area, for example? Would you expect the default rate to be different to the one you have in companies in Central or in TSD? I think you got your answer there, right?
Yeah.
Well, thank you, Calvin and Rodrigo, for their very good presentations. Let's take a 5 to 10 minutes break, and then we will have another talk in at around 2:20.